Hello everyone, we are from Group Chat and today we will discuss a pressing public health issue in Jakarta, the link between reservoir air pollution and the rise in ARI, acute respiratory infection case. As a megacity with high vehicle mobility, Jakarta often records PM 2.5 levels that exceed safety limits. This problem is crucial as it directly impacts the health of millions and put a heavy burden on the capital public health system.
Based on this issue, we have formulated our primary data question. Does the daily increase in PM 2.5 level in Jakarta significantly correlate with an increase in respiratory clinic visit? We expect our finding to identify trend pattern that can assist the city government in implementing preventive policy such as public health warning when pollution reach hazardous level.
Here, we are using a public dataset related to air quality and health records in Jakarta. As shown on the screen, our dataset includes several key variables data. The observation data, PM2.5, fine particulate matter as a pollution indicator. District specific location within Jakarta. This is structural data consisting of both numerical and categorical variables.
Now, before we get to analyze the data sets, we must ensure the data is clean. So, first of all, the data that I'm gonna use is this one. This is the first data set that I'm gonna use. That is, we're gonna check the data from year 2021 from this one, and also from this one. We'll take the year 2021. And also the variable that we're gonna check is the PM 2.5, because PM 2.5, the size of the particle matter is 2.5 micrometer. That actually is it's quite small, but it's actually more dangerous. So we're gonna check the differences between two files from using the code from Python, and we're gonna use pandas to calculate, and we're gonna use this matplotlib for so you don't need to see a bunch of data that will make your head like going to burst out. So the matplotlib is we will see later to make you all who see this video see the the graphicals that the graphic the graphic is easy to understand. So first of all, that you're gonna use that I'm gonna do here is to calculate from the first file, this one, the first from 20 to 22, and the second one is the file that contains 2010 to 2025, and this is the code that you might don't have to read them all, and we're gonna go ahead to run the code and let's see the output of the code. All right, here it is. First, the code has shown the output. The first, this first data set and second data set. There's actually no missing, no missing variable from each day at year 2021, which I already filter the 2021 from this code here, and then for the duplicated, there's also no duplicated from both data sets. But we will see the value instead. We can see the dataset first main and the dataset second main. It's very huge difference. As you can see, there's 20 point gaps in here. And then as for the graphical, so this is the graphic, the graph. As you can see, there's huge difference between this, the first dataset and the second dataset between the same year. And also, the first one mean at between 40 and 50, and the second one, the mean is between 60 and 80. The second one is actually show that the air pollution is high at the PM 2.5 value. It's higher than the first data set that only show between 40 to 50 microgram per cubic meter. Right, so that's from me.
Now let's explore the pattern. I will generate a scatter plot to visualize the correction between PM 2.5 and respiratory visit. Notice the trend. Here is a positive correction where clinic visit tend to rise as PM 2.5 levels increase. We also perform summary statistics using the F described to understand the average daily case during peak population period.
So, in conclusion, our data shows a strong link between air quality and the respiratory health of Jakarta's residents.
These findings emphasize the need for stricter emission regulation and public health strategies.
This investigation demonstrates how data science can translate real-world problems into actionable insight for public health discussion making. Thank you for matching.
Alright, thank you for watching everyone.